Hey there, I got a super special video for you guys today. I'm out at the site of Project Pando, which I did a video about last year, and it is a nonprofit organization that will be developing and growing native tree species to give away to the community surrounding Raleigh. And it's super cool, but today's especially important and cool because we're visited by Mark Shepard, and he's here to help set up all of the site design and the water management, all that kind of stuff. And if you're not familiar with Mark Shepard and his work, he's done so many cool things for the agriculture community and permaculture world. And I'm really excited to catch up with him and chat with him for a little bit. So he's written several books, and I'll leave those linked down below. But otherwise, hope you enjoy. Mark Shepard, thank you so much for taking a few minutes today to talk with me. If people aren't familiar with what you do, can you just tell people a little bit about your background?
A little bit about my background. Oh my gosh, how much time do you have? 3 days?
Whatever you want, Mark. Whatever you want.
So, well, I'll only go back 26 years now. For the past 26 years, I have been farming in southwest Wisconsin, 110 acres. New Forest Farm is the name of the place. When I got started, I had recently finished permaculture design course training, and I had certified with Bill Mollison for advanced permaculture design and training. And the goal was to take over a typical row crops farm of the area, which was focusing primarily on corn and beans, then transition that into a perennial ecosystem based on what used to be there and what persists in the area, which was the oak savanna. Now, the oak savanna is characterized by a suite of perennial plants with a canopy layer, a high layer of oak, chestnut, or beech. They're Fagaceae. Then an understory of cherries. Under that would be apples and hawthorn. There'd be plums as a shrub layer, hazelnut in a shrub layer, raspberries and blackberries as cane fruit, grapes as vines, currants and gooseberries in the shade, forage and animals running all around underneath it, and then fungi. There's leaf decomposing fungi, wood decomposing fungi, soil-borne fungi. And so what we did is intentionally designed the system with those species in the system, knowing that it would take time for them to start to kick in and produce. And between the rows of all those species, we did our farming, annual crops farming, everything from corn and beans eventually into certified organic produce. I was one of the early members of the Organic Valley Cooperative, which not a lot of people realize that Organic Valley started as a produce cooperative. A handful of growers got together, grow a certain amount of product to get it on a truck to take it to large markets, wholesale, and then eventually expanded into dairy and eggs and so on. So I've been a member of Organic Valley for 26 years since it was a wee little cooperative. And then livestock are part of the system, mostly cattle and hogs, and then my favorite, of course, are the pigs. As far as perennial produce was concerned, end up putting in 2 acres of asparagus, which is one of my favorite crops in the whole wide world. It's just so wonderful to grow asparagus. So that's just a snapshot of what I've done for the past 26 years. Well, then also what I do is I help other farmers to make the transition to do the same thing. And this film right now is being filmed in North Carolina, where I'm teaching a workshop and designing a system for the Triangle Land Conservancy. And what's the name of the other?
Leaf and Limb.
Leaf and Limb is the one of the organizations that's going to be managing the system through time.
Very cool. And I've done a previous video about this project right before it started.
Oh, cool.
And so I'll leave a link for people to check out about that too.
Did you film right here in the spot then?
Yeah.
And so were you here before they brushed out the?
Yeah, I don't think any of this stuff was cleared out over here.
So one of the things is that this site being abandoned agricultural land. First of all, let's say throughout 300 years ago, this was probably a pine savanna, where overstory of fire-resistant pine and all kinds of grasses and wildflowers underneath and different shrubs that are here. All the indicator species are here. It's just more of a pine oak savanna mix, and those will be the species that we use in the design because they have the best chance of surviving and thriving here. Well, then it was cleared and then farmed in primarily tobacco, I guess cotton early on, and then tobacco for a couple hundred years, and then it has been abandoned for a period of time. It's grown up with what we call invasives, a lot of privet and a lot of what the heck else is out here? I just look at it and see, oh yeah, right, my friend right behind me, the Bradford pear. So there's all kinds of what are considered invasive species here. So they did a reset and ran a forestry mulcher through a lot of this, retaining a lot of the native species with it. Now we're going to design the system on that land and start over.
I'm really excited to see the transformation with this project as well, and the input from all your knowledge. So I want to talk to you a little bit about your background a little bit more, and I know people may or may not know a lot of the work you've done. I know with a lot of other farmers, but also on your property. How's that gone over, you said 20 years? At that?
26.
26. Yeah. How's that progression been? Has it gone the way you thought, or like, I know there's always like meandering path with that, but like, have you, you know, so can you talk about that? I mean, a lot of people don't put that much time into one project, especially one that's kind of different.
Kind of different. That's a good way to put it. Well, how has it gone? That's an interesting statement. Well, the proposition or the question that we asked ourselves 26 years ago is, can we transition from annual crops agriculture? By annual crops, I mean a crop that you destroy a three-dimensional perennial ecosystem, expose the soil, plant your crops, they grow for a few months, they set seed or fruit or whatever it is that you harvest, and then they die. So what annual crops, corn, beans, rice, wheat, all of those are annual crops, and it's about almost 50% of the USA right now is annual crops, which means that we've taken 50% of the ecology that's our life support system. It makes our water, it's food, it's fuels, it's medicines, it's fibers, it's wildlife habitat, pollinator habitat, it takes carbon out of the atmosphere. We've destroyed 50% of this continent's ecological productive capacity and turned it into dirt. And the question was, can we now have this farm operation reverse the process and reinstall a naturalish ecosystem that is now perennial while still paying its own way? And so to answer that question is, well, yeah, we can. It does. It works. The model works. The methodology works. What bothers some people is they want me to be standing on a soapbox say, oh yeah, you do this and you can make millions per acre, crushing it. It's all like, no, wait, time out. Nobody's making any money in agriculture. Get over it. There are people who have special circumstances. Maybe mommy and daddy gave you 300 acres of land for free, and you're only an hour and a half from Washington, D.C., where people buy food for status instead of health and nutrition. The majority of all of us get our food from industrial-sized systems. Well, most of this audience, from what you just told me, we're small-scale homesteader, farmer market gardener types. We don't want to have 8,000 acres of whatever. Well, what I like about the Organic Valley model, we can do our thing at the small scale, but when we collaborate with one another, pool our product together, all of a sudden we're a big company, and now we can access the mass market for our products. So a lot of permaculturists, permanent agriculture, when I was trained by Bill Mollison, a lot of permaculturists have taken one of the permaculture principles, which is make small and slow changes instead of a big change that's wrong. That has become interpreted to mean that permaculture has to be small, but it never said that. You go right back to Bill Mollison's writings, all of what he taught, etc. Make small, slow changes. So here's a small, slow change that I would like to see happen. One small, slow change. Let's take all of the annual cropland in the USA, which is 50% of the land surface, and let's just make a little change and convert it back to the ecosystems that it was prior to European arrival. That's just a small change, but it's hundreds of millions of acres, and it produces so much food, fuels, medicines, and fibers that we can convert all of the annual crop fields in the US of A to mixed perennial systems over the course of 15 or 20 years that can pay their own way. Will they make $10 million an acre? Not necessarily. They're not making anybody any money anyways right now.
What I find most fascinating, I think, about your farm model and a lot of your work is that you do have an output. You are making money from the land, and it isn't this complete focus on regeneration. It's a combination of like production and regeneration at the same time.
Right.
Can you talk a little bit on that sort of balance of like, you know, how do we pay our own way and still make some money and still grow some food at the same time, you know, trying to work towards the goals that you're working towards?
Yeah, this could get complex. It's not complicated, but it can get complex. I'll just point to my shirt. I'm obviously wearing my work shirt today, but the consulting portion and the design portion of what I do is restoration agriculture development. We can do ecological restoration, but not the kind of ecological restoration that most restoration ecologists do, where they try to make an ecosystem fit a snapshot in time of what it should be in its wild state, and then they maintain it with herbicides and trimming and cutting and volunteer work days and all that. So that's a massive input of labor and expense. Well, we can do that while producing agricultural crops, our food, fuels, medicines, and fiber, have the agricultural output be what's generating the revenues for the ecological restoration, if you can follow that. Well, what that ends up being is development, because what we can do is we can take a clear cut, which is how I got started with clear cuts, or a degraded farm, both of which were abandoned by the previous landowner because they extracted everything they could out of it. We can take that and using ecological principles of succession, change through time, we know that it eventually will turn into this over a long period of time. So we'll go in and preload it ahead of time with the plant community type that belongs there, and then we farm in between and use the revenues to pay for the restoration of the property. On the economic side of things, like I said, too many people want me to come up and say you're going to make zillions at this, we're going to make, you know, more food per acre than everything else, and I've never said that. What I have said is you can have a profitable farming enterprise, but it's not likely to pay for all of the bills everywhere. Now let's take this line right here and call it $0. If you're going to grow, let's say, apples, for example, you buy the apple trees, you do the weed control ahead of time, 3 years worth of preparing the soil and cover crops and fertilizer, and then you plant these trees that are 4 or 5 foot tall, and the deer protection, the fence, the irrigation, the fertilizer, the fungal sprays on a 10-day cycle or whatever is going on in your particular area. You have all these expenses. You may go 5, 6, 7 years before you ever generate a dollar revenue at all. So you're going in the hole deeper and deeper and deeper and deeper. Well, what if we took this 0 right here as our 0 line, instead of setting up a system that starts by burying you in the hole because you're being told by the university how you have to grow apples, let's grow them like a wild natural system. You're not going to get the yields that way. Yeah, that's right, because we don't care if we're going to get the yields that way, because what we're going to do is we're going to put them in at an expense, so now we're below 0. And then when we go out there and interact with this system, we're going to get a yield out of it. Maybe we're going to trim some branches that we then lay right on the ground to decompose with our very special mushroom spawn that we got somewhere, some like say winecap strophareas. Now we're decomposing the wood, which is releasing nutrients as fertilizer for our trees, and we're producing stropharia mushrooms as a crop. Will we be producing so many stropharia mushrooms that we're going to have a business that pays all of our bills? No. Worst case scenario, we get to eat mushrooms every day when they're flushing. So if every time we go in there, we get some sort of yield out of the system. So if you're going to plant apples as an orchard, instead of mowing the grass and adding fertilizer, why don't we turn cattle loose and graze in between the rows of apple trees? Are we going to have a $1 million business of cattle grazing? No. But if I get, say 10 cattle, because I can do 10 math, right? If I have 10 cattle, I buy a 500-pound steer in the spring, somewhere around $1 per pound at the local auction barn. No special genetics, none of that, none of the fancy crap. It's just get me a steer. You put the 500-pound steer on the property when it turns green in the spring in May. By the time September, October rolls around and grass starts slowing down, at least that's what the season is in Wisconsin, you now have an 800-pound animal. Then you sell 9 of them at the sale barn for the same around $1 a pound. You've just made 60 to 120% return on your investment. That's phenomenally profitable. But if I now sell 10 of these animals at what's 8 times $800, so $800, right? Is that going to pay my bills for everything? No. But if I take 10% of those profits and put it in the freezer, I now have all the beef I need for the whole entire year. I fed myself. So now that expense of my own food goes away. And I got my mushrooms are part of the fertility regime for apple trees. Then if I have wildflowers, let's just put daffodils, for example. Daffodils underneath an apple tree will outcompete the sod. Now I have a sod-free orchard floor that's producing cut flowers in May. I now cut all these flowers and go sell them for 10 cents a stem somewhere. I'm getting weed control with a revenue stream. If I sell daffodils, is that going to pay all my bills? No, but I'm getting weed control along with that. I'm getting the grass control, and what do the cattle contribute? Their urine, their manure. They're adding fertility to the site. And in the fall, once apples have been picked, you put the cattle in. They start eating all the leaves that fell off the trees. If there's any apple scab, for example, spores on the leaves, you want those leaves off the orchard floor. So let's get the cattle in there when the grass isn't growing very fast and they got their nose real close to the ground. They're eating a lot of these leaves. The apple scab spores are getting digested in the cattle's stomach. So now you're removing the spores of a disease in your orchard while making 60% return on your investment on cattle, filling your freezer full of beef in a system that's producing mushrooms for you, cut flowers in the spring that are getting rid of the sod underneath the apple trees. How much more do you want me to keep adding into the system? Because it goes on and on and on from there. When you design a three-dimensional, as complete an ecology as we possibly can, and when we do that, imitating the natural plant community types of the area, and then using disturbances, inputs into that system that mimic the type of disturbances that they've had historically through time. And in this area right here in North Carolina, this was fire and grazing primarily, and windstorms that were the major disturbances to the ecosystem. We can mimic those disturbances and it will behave just like a natural system. And because we've preloaded it when we plant the system to produce food, fuels, medicines, and fibers, it'll generate positive revenues. We've eliminated the costs of all the input costs of producing apples, for example. We've put meat in the freezer, mushrooms in the canning jars and freezers and dehydrators, cut flowers as a revenue stream, and maybe at the end of the year we make a couple of bucks, but what are our expenses?
And you're eating.
Quite well, thank you very much. I probably weigh 230 pounds. It takes a lot of feed to keep a 230-pound animal alive, and if you don't believe me, try keeping a 230-pound pig alive. It's a lot, like 14 pounds of feed a day to keep a 30-pound or 250-pound pig going.
Right. I want to ask you a little bit about your tree work. I know that's something you spend a lot of time and energy and over the time. Can you talk a little about the work you've done with that, and also the network of nurseries and some of that stuff that you're working on?
Okay, so now the tree work. I'd already mentioned that this right here, Restoration Agriculture Development, is the design and consulting and installation part of what we do. The nursery is Forest Agriculture Nursery, and you can look that up online at forestag.com. What Forest Ag is, it's a edible woody crops nursery, and unlike a typical food woody crop nursery, say apples, I'll use apples as an example, maybe stick with it. What they'll do is they'll find these individual top performing plants and then clone them, either through grafting, tissue culture, mound layering, stool bed, greenwood cuttings, hardwood cuttings. And you have, if you go to the grocery store and get a Red Delicious apple, that's off the same Red Delicious apple. Even though there's 10 million individual plants, they've all been grafted with the same plant. The Macintosh apple, for example, was discovered on a fence row in like 1839, I think it was. So since 1839, that plant has not reproduced itself. It's been this Macintosh apple. And we keep reproducing that genotype, the genes that it has, but it's not an active participant in reality the way it is. We work with seedlings. And if we use apples as an example, is we'll take all these apples from all around everywhere. Originally, my apple population was started with 239 named apple varieties. Had about 3 or 4 individuals of each named variety, and then planted them in rows and took minimal care of them. No pruning, no fertilizer and weed control other than like planted associations with flowers and livestock moving through the system, and no pest or disease sprays, period, none. Been certified organic since 1995, and personally have never used any kind of pest control or disease control in any of the systems. Well, so what happens is you'll have some apple trees that get every disease under the sun, every pest under the sun, and other ones that for some reason nobody bothers it. So then, okay, we'll take the ones that no pest or disease is bothered, graft them onto the roots of the ones that started to die, And then we save the seed. And well, we're told, well, don't save the seed from your apples because they won't come out true to type. Well, examine that statement for a while. Can you name for me anybody anywhere who's planted an apple seed in the ground and had it turn into anything other than an apple tree? Hello, they come out true to type. It's an apple. What it's not genetically identical to its parent or its parents.
Exactly the same.
The apple is not going to be exactly the same. So what modern plant breeding does is it controls the pollen cloud, who gets pollinated with what, and then once a high-performing individual is discovered, it gets propagated through tissue culture, stool bed, grafting, etc. And then they push this individual, and you plant a monocrop of an individual, and then when reality happens, when pests come in, when diseases come in, you call it a problem. Now you fight against a problem with sprays, whether they're organic or chemical, and cultural practices, and that's been a losing proposition ever since it's been begun. So what we do is we're breeding for population fitness. And so my apple orchard is this way, my hazelnuts are this way, is that we want the whole entire population to be successful where it is, with the soil the way it is, with the climate the way it is, the rainfall patterns, the grazing harassment, whatever happens to it, the population of plants is what's durable, what's performing. Well, within there's going to be high-performing individuals that we will go ahead and propagate out, and then we put them side by side, and then we have them breed, and we save the seed, and we do it again. So we're constantly breeding our way forward through time, and our main selection criteria are fast to reproduce, pest and disease resistance. And you can do that with any plant. And as long as you're happy with having apples that taste good, what's wrong with that? This apple right here, what variety is it? Who cares? It tastes delicious. It makes a great juice. I have one apple variety that I call it lace because I marked it with a bootlace. I'm out in the middle of where the trees are. I was like, wow, nothing's bothering this. It's delicious. It was a little bit dry, but it was fantastic. There were no pests in it whatsoever. To this day, there's no insects that burrow into it. No codling moth, no railroad worm, none of that. So I marked it with a bootlace, and after a while I'd graft it and send friends, here, try one of this, try that. Figured out that bootlace is probably not the best marketing term for an apple.
How do they name apples? I was always curious. I guess that's how it goes down, huh?
So I call it lace. So it's lace. Well, lace, you can slice it and you can put it on a picnic table outdoors in the rain, and it will dehydrate and not turn brown. It's like, what? I didn't even have to genetically engineer scorpion venom to put in it. All I had to do is save my apple seeds and put them in the ground. So that process of mass selection breeding is how we operate with all of our woody crops. And so the genetics, if you planted trees, hazelnuts from us 10 years ago, they're genetically different than the hazelnuts that you'll get this year, genetically different from 5 years from now, 10 years from now. Well, then as other growers get plants from us, now we encourage them to participate in the same mass selection breeding. Save the seeds. Plant a high density bed, the ones that produce really fast, high yields, pest and disease resistance. Save those seeds and plant it again, and plant it again, plant it again.
So the sort of genetics stuff that you've been working on is applicable to where you are. Like, how do you then push that onto other regions, other areas? Like, how does that work?
Right. So then what I do is like I was talking with the leaf and limb folks right now. They want to do a nursery here with plants adapted to this region. So if they would get the foundational stock from us, we plant it in the ground. The ones that are suitable for here, that the population that does really well here, pest and disease resistant, highly productive, really to reproduce, they save that seed. They propagate that again. They start their own breeding program here, and then as they're planting, it's larger and larger. Then the bulk of the seed goes off to our nursery. We produce hundreds of thousands of them at scale, and then that gets sold to other folks, and everybody ends up being a breeding site for these plants.
So sort of building out a network so that there's more locally adapted plants for different regions.
Correct. And the big three that we really concentrate on are hazelnuts, chestnuts, and Korean pines, and we flirt with these other ones as well, but those hazelnuts have responded particularly well, really fast. So we have enough growers in all parts of the country, except for California, Oregon, Washington, where we're not allowed to ship plants to, that now participate and have the seed shipped to our nursery guy on the ground, who then grows them out. So if you're in North Carolina and you want to order hazelnut plants, we get them as closely adapted to North Carolina as we have within our network. You know, from Maine to Florida, Texas, Oklahoma, we've got, you know, folks that are participating in the breeding program. So hopefully this site right here will now become another source of locally adapted hazelnut genetics.
Cool. I hope to document that over the course of time too.
Good.
Absolutely. I want to switch gears a little bit. I know personally myself, and I think a lot of people watching this are interested in permaculture.
Right.
It's sort of like the gateway into a lot of this sort of thought process and this whole world of sustainable ag.
Right.
And I know that you were trained by Bill Mollison originally, and you've been in this a long time. Can you talk a little bit about how you're feeling about, you know, the sort of permaculture and the permaculture community right now, and maybe how that's changed, or for the better or worse?
Well, I'm not gonna badmouth permaculture with a capital P. What I'm gonna do though is I will support and defend permaculture as was described by the person who kind of thought about it the most in his life, the founder of it all, Bill Mollison. It meant a certain specific something. What I liked about it that really resonated with me is that it was based on a set of ethics. That's earth care, people care, and the third one, which I like to call future care. We got to care about the future, reinvest in the productivity of our system to go forward. And so one of the things that I would like to encourage all permaculturists to do is to have reality-based solutions. When you do something, really solve a human problem. I'll pick on the cob oven just because. Can you tell me anywhere how a cob oven is permanent agriculture or permanent culture? It's a really cool little detail, but it's not going to feed you. And if you're in Vermont, for example, where there's no clay, this is an inappropriate technology. We want it to be a context-based solution. So a North Carolina permaculture site is going to be different than an Arizona permaculture site, different than Alaska and Manitoba, etc. So come up with context-specific solutions that actually are solutions, and then not at the level of play. Oh look, see, this is cute, we can grow a berry bush in a hugelkultur in our backyard, isn't that wonderful? Who does it feed? Let's produce our food, our fuels, our medicines, and fibers at scale.
So what's exciting you right now in the world of agriculture, and what do you have like looking forward? Like, what are you excited about right now?
Well, what I'm excited about right now is how much this has been taking off and growing in interest. Is that once upon a time I'd be out here talking about this crazy stuff and people like, wacko. Well, they still do that, but there's more and more people that are wacko along with me, because if you look to nature as the model, it has been working ever since the beginning of time. Whether you think time started 6,000 years ago or 6 million or billion years ago, these natural plant community types here, they have been here, they have persisted, they've handled hurricanes, droughts, floods, humans cutting them down, fire, elephants. There were elephants around here that used to knock things over. These plants, plant community types, and the animals associated with that have persisted since forever. It's time for human beings to design our lives and our culture around nature as the model. And that's what excites me these days.
Awesome, Mark. Well, I really appreciate you taking the time to chat with me and all of the work that you've given back to the community and the world. And nice to see you in the Southeast as well.
You as well.
So I will leave links down in the below to all your work, and if people want to, get in touch with any of the stuff that you're working on.
Good. And check in again in the future, and let's follow up with stuff. So cool.
Thanks, Mark.
Thank you. Bye-bye. What's this spider crawling on my hat? It's pretty cool. Is it a spider?
No, it's just a leaf.
Oh, so it's crawling. Leaves don't crawl. So anyways, so I'm just gonna rant. Yeah. Start again?
Yeah, we'll be all right. You like talking?
I mean, what? That'll be an outtake.
Yeah.